Java Review Loops. Are you noticing how algorithms could get very long and repetitive? This is where repetition or iteration comes in. Iteration is when an algorithm repeats steps rather than listing them sequentially over and over. The flowchart below shows iteration. Notice we will use the diamond to represent whether the procedure will be repeated. If not, it exits the iteration. Let's take a look at a classic example, the instructions on a shampoo bottle. The directions are to wash, rinse, repeat. Sequentially, that would be represented like the flowchart on the right. Wash, rinse, end. What's wrong with this? It's a bit redundant. You have wash and rinse in there twice. What if the instructions for this specific shampoo were to wash and rinse 4 times in a row? That would look like this very long flowchart on the right. What about 10,000 times? That would be a very long and redundant program. However, computer programmers are constantly asking their computers to run repetitive tasks of thousands of steps. You might be saying, is there a better way? There sure is. Iteration. Iterations need something that was not considered before with sequence: conditions. A condition is something tested before the iteration runs each time. It will only run if the condition is true or yes. This way, when the condition eventually is false or no, the iteration will end. In this case, with the shampoo bottle, when would be a good time to stop washing? Well, when your hair is clean. So we want to continue the iteration as long as your hair is dirty. So wash, rinse, check to see if your hair is dirty. If it's still dirty, we're going to repeat the wash, rinse cycle. If it is no longer dirty, then we will exit the loop. What makes computers so useful is that they can perform repetitive computation without guidance. We'll review a few types of loops that can be used to repeatedly execute a set of statements. The first is called the while loop. The syntax is similar to an if statement. While condition, then we have the body of the loop inside here, then end while. The condition is tested first, and if it's true, the body of the loop is executed. If the condition is false, the program exits the loop and continues on in the program. Below is an example of a loop that goes on forever. It will print out hello an infinite number of times. While true, print hello end while. In computer programming, we must avoid creating infinite loops. They will crash your computer or the computer of whoever happens to be running your program. The following example uses a variable to count from 0 to 9. The condition I is less than 10 is true as long as I is not 10. When I becomes 10, the loop terminates. So here, above the loop, we declare this variable I, set it equal to 0. Then here's the condition. While I is less than 10, the loop will continue to print I. Then, this is the most important step here. I is increased by 1 prior to being tested again in the condition. Don't forget this step, or I will always be 0, and therefore the loop will continue forever. Loops should not go forever. There are 3 rules when creating loops. Number 1, the variables in the condition must be initialized. 2, the condition is tested before the loop begins. 3, at least one of the variables changes value within the body of the loop, eventually leading to the condition being false. When using a loop, one variable is always a counter, so that the loop only runs so many times. The variable starts with a whole number, counts by any number, not just by 1, and then ends with any number that does not satisfy the condition. Here's an example. This loop counts from 1 to 10 by 1s, so 1, 2, 3, 4, etc. We declare x is equal to 1. While x is less than or equal to 10, we're going to print the value of x, and then we're going to increment x by 1. So this will the first time through the loop, x is 1, it will print 1. Second time through the loop, x is 2, it will print 2. And it will go all the way, and it will print 10 because we have that equal sign in here. So, yep. The while loop is good, but it is quite a bit of typing. The for loop does the same thing, but in a much more compact way. Neither one performs faster or better than the other. The general syntax of the for loop is shown here. Notice that all three requirements of a while loop occur within the parentheses of a for loop. The variable is initialized before the loop begins. The condition is checked before the loop runs each time, as like before with the while loop. And the last part is the change in value that will occur to the variable at the end of each run of the loop before being tested again. The following for and while loop are almost equivalent. So here we have our while loop. We initialize I to 0, and that takes place here in the for loop, initializing I to 0. Then we have while I is less than 10, and that is the condition here in both loops. And then we're going to increment by 1. So I is going to be set to I plus 1, which will add 1 to the current value of I. That takes place here in the for loop. Variables declared in a for loop are only defined within that loop and only exist within that loop. This allows them to be reused. The following example shows two for loops, one after the other. The second for loop can use the variable I again. So here, this I variable only exists in this loop. So once this loop is over and the computer goes to the next for loop, this I is going to be a different I. So it will reset to 0 and can be used again. The scope of a variable refers to the sections of code that can use it. When the initialized I is used within a for loop, the scope of I is only inside that loop. Other code outside the for loop can't see that specific variable I, hence why it can be declared, initialized, and used again. In this example, I in the first for loop is a totally different variable than I in the second for loop. This is legal because each variable only exists inside its own loop. The code below has a compiler error because once the computer leaves the for loop, which is the scope of I, it forgets I entirely, as if I never existed. So here we declare and initialize I, we use it as our counter variable in this for loop. However, we cannot then access I outside of that loop. So the error exists as a result of this statement. If you want to reuse the variable I with multiple while loops, you would have to reset I to 0 after each loop. You do not declare it again. Only use int, shown here, the first time you declare the variable. This method might be confusing and is not recommended. So here we declare I, set it equal to 0. We use it as our counter variable in this while loop. Then, after that loop is over, we go to this line, we reset I to 0, then we can use I again. But yes, once again, this is not recommended. Practice with for loops by identifying what would be printed below. Alright, so I'm just going to talk through what's going on here. I is set to 5. 5 is greater than or equal to 0, so we enter the loop, we print the current value of I, which is 5, and then I is decremented by 1, which means it gets lowered by 1, therefore I is now 4. We go back to this step. 4 is greater than or equal to 0, so we enter the loop, print 4, and then I becomes 3. 3 is greater than or equal to 0, so we enter the loop, print 3, and then I becomes 2. 2 is greater than or equal to 0, so we enter the loop, we print 2, then I becomes 1. 1 is greater than or equal to 0, so we enter the loop, we print 1, and then I becomes 0. 0 is greater than or equal to 0, so we enter the loop, we print 0, and then I becomes negative 1. -1 is not greater than or equal to 0, so we exit the loop without printing anything else. So the output for the program is 543210. What is the output of this for loop? All right, so let's take a look. This loop is very similar to the last example, except this time I is initialized with a value of 10, and the condition is I is greater than or equal to 1. Therefore, during the first iteration, I is 10, 10 is greater than or equal to 1, so we enter the loop and we print 10. Then we lower I to 9. 9 is greater or equal to 1, so we enter the loop again. This continues all the way down to 3, 2, and 1. Once I is equal to 1, it will enter the loop, print 1, I becomes 0. Then the condition is false and the loop is exited. So this is what the output for this program looks like. The following for loop starts with I equal to 1 and then doubles each time. Notice the expression that doubles the variable right here. I becomes I times 2. So instead of adding 1 or subtracting 1, we can multiply by 2. Can you identify the output of this loop? The answer looks like this. Let's see how that works. So initially I is 1. 1 is less than 16, so we enter the loop and we print I plus a space. So the current value of I is 1. That gives us that 1. Then I is multiplied by 2. 1 times 2 is 2. 2 is less than 16, so we go into the loop, we print 2. Then 2 times 2 is 4. I becomes 4. 4 is less than 16, so we go into the loop and we print 4. And so on, until we get to 16. The code segment below is meant to output all factorial values from 1 factorial to 6 factorial. Recall that factorials should yield these values. 1 factorial is 1, 3 factorial is 3 times 2 times 1, which is 6, etc. However, this code contains at least one error. Can you find it? Correct! The variable int n was not initialized. Because we want the program to calculate 6 factorial, we will need to initialize n to 7. Or we could change the loop condition to have this equal sign in there and then initialize it to 6. So now the program will run with no errors. Let's try it. So see, by having n set to 7, that makes this 7, so I will start at 0 and then it will go up by 1 until it's less than 7, which will give us 6 factorial. Do you get the values you're expecting? While the program ran without errors, it did not run correctly. There were 2 mistakes in here that would lead you to not get the correct results. Number 1, factorials multiply prior values. They do not add them. Also, once the operation changes, so we change this operation from a plus sign to a multiplication sign, so the initial value of fact will be a problem here, because if you have a 0 in here and you're multiplying it this way, you are always going to be multiplying by 0. So this version of the code here is going to run without errors and correctly produce the expected factorial values. We have to initialize fact to 1 instead of 0, because otherwise this will always be 0. So if this is 1, then we will get the desired results. In order to deduce where the logic errors were within the factorial code, we conducted what is known as empirical testing. Empirical testing involves the actual testing and observation of the results of testing. This means in programming, code must be executed and the results provided. Then the results are observed to see if additional modifications are needed to ensure the correct output. In the factorial program, we ran the program multiple times and made changes each time to improve the output. Proof of induction testing could also be used when developing an algorithm like the one used to calculate a factorial result or iterating over a series of numbers. Proof of induction is a method of reasoning founded on a base assumption and a hypothesis where if both are proven true, The algorithm will then apply for any value given. Using the factorial program as an example, using proof of induction means that a base case in this example is when the code would end, which would be when n is 1. If the algorithm successfully works for n equal to 1, then the inductive step would prove that the algorithm successfully works for n plus 2, or n is equal to 2. If both are successful, then the code has been tested using proof of induction. Let's take a look at how a nested for loop works. For the outer loop, x is going to start at 0. Then we enter the for loop, and now there's another for loop. So x is 0, y is 0. It will print 0 and 0, like this. Then the inner loop will run again, and y will be 1, but x is still 0. Therefore, it will print 0, 1, and so on, 0, 2, and then 0, 3. Then, once we're back at the outer loop, x is incremented by 1, therefore x is now 1, and the whole thing repeats. So x is now 1, we enter this loop, y is set to 0, we print the value of x, which is 1, then the value of y, which is now 0, and we loop through. So we have that same value of x for every time it loops through the inner loop as y is incrementing. And this goes on until the outer loop is done when x is 2. So x is 2, the whole thing will repeat again, but then once x becomes 3, the loop breaks. Nested while loops behave the same as for loops. Below, for each value of I, j cycles through all the values 0, 1, and 2. You may see what is known as a do-while loop on the Praxis exam. Although a do-while loop is used in Java, it is not covered in NJCTL's AP Computer Science A course because do-while loops are not on that AP exam. A do-while loop differs from a while or for loop in that it guarantees the statements within the loop will be executed at least one time. After the statements are executed at least one time, a condition is checked to determine if the statements will be executed more than once. Let's walk through the example below. A variable guess stores the value 8. A statement prints 8 is not 1 yet. And then there's an if-else statement. That's going to determine how guess is changed. So if guess is an even number, which means guess modulus 2 is 0, that would be true for all even numbers, then guess will be decremented by 1. If guess is an odd number, then it will be decremented by 2. So this will loop through. Guess is going to be checked here. If guess is equal to 1, then the loop will break. A repeat until loop is a type of loop that is unique to block-based coding and can be found on the Praxis exam. It is similar in structure and functionality to a do-while loop, as you can see by the general syntax outlined below. A repeat until loop differs from a while or for loop in that it guarantees the statements within the loop will be executed at least one time. After the statements are executed at least one time, a condition is checked to determine if the statements will be executed more than once. This way of functioning is identical to how a do-while loop works. We'll modify our do-while loop from before and turn it into a repeat until loop. So here we have repeat until instead of do while, but the rest of the code is the same.